Am I recording? I think I am. Hello and good day, Algebra. We are wrapping up Unit 1 with what are called arithmetic sequences. What does the word arithmetic mean? Back in first grade, second grade, your math class was called arithmetic because basically all you did was learn how to add and subtract. Okay, the word arithmetic means to add and subtract. So when we talk about an arithmetic sequence, if you think about the word sequence, what sorts of things come to mind? Patterns, right? So an arithmetic sequence is a pattern involving addition or subtraction. Yesterday, we filled out this table here. We wrote a rule for the table. What we did was we projected, if we are continually adding 32 over and over and over again to work through this table, right? This is a pattern with addition. You're adding 32 over and over and over again. We were able to write a rule to predict the distance after 38 seconds. That's what an arithmetic sequence does. When you've got a pattern with addition or subtraction, you can come up with a rule, come up with an equation that will help you predict things. You don't have to just continue on the table, because that can be very, very tedious. Okay? And so you should all have those notes in your binder here. So, arithmetic sequence, a pattern using addition or subtraction. Okay? A pattern using addition or subtraction. And one little caveat to that here, it says this little careful. It says a sequence is only arithmetic if the pattern is a constant addition or subtraction, right? Constant. The one that we had up on the table, it was constant. It was adding 32 every single time. The difference would be if you had a pattern that like added 1, then added 2, then added 3, then added 4, then added 5. That is a pattern, right? It uses addition, but it's not constant. So that's the one little caveat there. That addition or subtraction has to be the same throughout. Okay? And here is the formula. This goes on a help sheet. If you don't put it on a help sheet, that is just foolishness. Okay? AN equals A1 plus N minus 1 times D. Crystal clear?
No.
Of course not. No. It's got a lot of variables here. Okay? Let's dissect this a little bit. Okay? The AN, I gotta calibrate, hold on. I'm gonna impress you with my accuracy.
Okay.
There it is. Right in the middle. Greens throughout.
15 DPM.
The AN term is the number
All the hours of Mario paid off.
of the term you want. Okay? The number of the term you want. I should say the number of the term in the sequence. I should add that here. The number of the term in the sequence that you want. Okay? So in our example above, when I asked you for write the formula and calculate the distance after 38 seconds, what number term of the sequence were we trying to find? Dominic? Right, but in our specific example up above, where I said calculate the distance after 38 seconds, not the fifth. Initially, yes, but then when I said calculate it after 38 seconds, we wanted the 38th term, okay? So in our example above, AN would equal 38. Or, hold on. Yes, we'll scratch that. This is the answer. Okay? A1 represents the first term of the sequence. Okay? AN is the number of the term that we want. That's the answer. A1 is the first term. And what was the first term of the sequence? What was the distance after 1 second? Where did the pattern start at?
16.
16. Okay? The n, yes.
Should the first for AN, should the answer be 38?
The answer isn't 38. The answer was 1200. We wanted the 38th term in the sequence, right? This right here, a1 plus n minus 1 times d gives us this. So I guess I can put it in here. Our answer was 1200. Okay, this arithmetic sequence, when we set it up using the above example, it's going to equal 1200, which was the 38th term. This n right here is the same n as you have here. An tells you what number of the term sequence you want to find. That number gets plugged in for n in the formula. Whenever you have a formula with the same variable, like we have two n's here, they equal the same thing. Okay? This says find the 38th term. That's what we wanted. So we would plug 38 in for n. So this one also represents the number of the term in the sequence we want. But this isn't the answer, this is the actual 38. Okay? It'll make a little more sense when we set it up down below here, okay? But I want you to remember, this n and this n, they are the same thing. Okay? And you'll see that shortly. And finally, D. D represents the common difference, which is essentially the pattern. What is the pattern with addition or subtraction? Which in our example, what were we adding over and over and over again? 32. Okay? 32. So, I'm going to write the formula down here. An equals a1 times n minus 1 times d. And we're going to plug these values in. Okay? Now, when you see this an, it's going to look like this. A38. That's the answer. Right? That's what this formula is going to equal. What this tells us here is that we want the 38th term. Which is why, when we get to n in the formula, this is also going to be, oh, I forgot the plus sign. Sorry, hold on. A1 plus n minus 1 times d there. When we get to n in the formula, this n minus 1, this is going to be 38 minus 1. Whatever number this is, that's what you're trying to find. That's the number of the term in the sequence you want. Okay, so those two things will match up. That's kind of why they have the same definition here. Only one of them eventually ends up being the answer. The other one is simply that 38. Does that make sense? It's not perfect, it's okay. Okay? But what I want you to walk away with is whatever this is here, that is also your n. Those two numbers are the same. This ends up being what the formula equals. This helps you find it. Okay? A1, the first term in the sequence was 16. And the common difference was 32. So we are multiplying that by 32. Go ahead, in your calculator, calculate this right here. 16 plus, in parentheses, 38 minus 1 times 32. And tell me what you get. Claire!
1200.
Fancy that! It works! Does everyone else get 1200? If you don't, then you're putting it in wrong, which is not going to be very good for the test. 1200?
1212.
Okay, check it again. Make sure you type it exactly. 1200? 1200, 1200, 1200, 1200. Okay?
I got 1264.
Check that you plugged it in correctly.
Oh, like these buttons?
Daddy,
These buttons.
can you figure it out?
I got 1264.
Try it again. Make sure it's exactly as you see.
Oh my
Oh, you
goodness.
said so you can't clear it? Oh. I can't clear. Alright.
Okay?
The bottom.
Now,
I need to take off the rubber.
so those that were confused a little bit before with this A38 and 38 here, you can think about this as if this is the answer for the 38th term. The 38th term in the sequence is 1200. So that's how this ends up being your answer. This formula gives you that 1200. This number here tells you what number of the sequence, what term you're trying to find, and that's why it's the same thing as n in the formula. Okay? Questions so far? I'm not expecting you to completely understand everything, but if you're completely lost, then this would be a good time to ask. Okay, so we are going to build up to mastery here, and we're going to start with this first part. It says, write an arithmetic sequence of at least 4 terms using the given first term and common difference. So we aren't tackling the whole formula at once here. We're only getting comfortable with A1 and D, that first term and the common difference. So if the first term of our sequence is 17, that's where things start. Our common difference is positive 6. What's the next number in the sequence? Christian.
23.
And how'd you get that?
17 plus 6.
Yeah. Right? If that pattern, if that common difference is positive 6, that means what's being done throughout the sequence is continually adding 6. So 17 plus 6 is 23. What would come next? 29. And then 35. Right? How we're getting from number to number here is we are adding 6. That's what the common difference tells us to do.
Why adding 6?
Because that's what we're told the pattern is in this particular sequence. That D variable is what the pattern is. That's why it was 32 in the last example, because in the table, we were continually adding 32. Okay? So for the next one, a first term of -4, our common difference is -3. What would that mean? Subtracting 3. What would the next number in the sequence be?
-7.
-7, and then -10, and then -13, right? What's happening between each of these numbers is we are subtracting 3 because we're told where we start, the first term. We're told what the pattern is. That's the arithmetic that is being done to get from number to number. Okay? The last one, where do we start? Nope, you don't start at -6, start at 5. But our next number in the sequence is -6, minus 11, right? And then
-17.
-17, and then -28. The difference between each of these is -11, and we know that because that's what the D value is. Okay? Questions so far? We're all in the same place. Henry? Okay? Anybody?
How do we know like when to stop with the numbers?
The directions say at least 4.
Okay.
Okay, we could go on. Okay. Next page, we are adding in another variable. We still have the first term provided. We still have the common difference, the pattern, but now we have this n here. It says, use the given information to find the nth term of the sequence. Put the values into the formula to solve. So remember, here's the formula. an equals the first term plus the difference of n and 1 times d. Okay? If we're looking for, if n is 12, if we're looking for the 12th term, what number do we put in for n here? 12. This says, this formula will give us the answer for the 12th term. Where else do we put a 12? In for n, right? Because this n tells us what number of the sequence we want. These two things will match. This tells you you're finding the 12th term. This will be the answer. This is where that 12 goes in the formula for n, the 12th term. Those two things are related. What goes in for A1? the first term?
6.
6. What goes in for D?
12.
The difference. 4. Positive 4. Okay? Go ahead and calculate this. What is the 12th term of the sequence, starting at 6 and adding 4 repeatedly? Matthew, what'd you get?
50.
50. Kyle, what'd you get?
50.
Grayson, what'd you get?
6,000.
Whoopsie-doo.
Sing it.
Try again, Grayson.
Sing it, Grayson. 6 plus. Would you look at that?
50 there. Woo! Okay. Anyone not get 50?
I got.
Okay. So the 12th term of the sequence equals 50. Okay? This is much more efficient than what we were doing on the previous page, where we just add 4 over and over and over again 12 times, especially when you're looking for the 80th term of the sequence. You don't want to have to subtract 3 80 times by hand like we did in the previous page. We have a formula. Or the 101st term, add 71 101 times. No thanks. I'd much rather use this equation here. Okay? Damien.
The right side of my calculator isn't working. The left side is. Like when I press the buttons, it's not doing anything on the right side.
Have you been abusive to the calculator? Drop it on the floor a lot?
No.
Step on it? Anything? No? Okay.
Oh,
I'll take a look at it. And take a look.
not mentally abusive.
Okay, next one. Again, with the formula, AN equals A1 plus, in parentheses, N minus 1 times D. You need to at least write out the formula. For these first 3 especially. Write out the formula here. We're looking for the 80th term, which means that the answer for the 80th term can be found by starting at 4, adding the difference of 80 minus 1, and we're multiplying that by negative 3, because that is the common difference. We're subtracting 3 over and over and over again. Okay? What do we get? Christian. Negative 233. Kyle, what'd you get? Negative 233. Grace, I'm afraid to ask, but what'd you get?
1 second.
So you don't have it right?
I put it in wrong.
Matthew, what'd you get?
Negative 233.
Okay, negative 233. The answer to the 80th term equals negative 233. Now, who can put on their math brain and tell me why this formula works?
Not me.
Rowan, why does this formula work?
Because the calculator says it does.
Okay? Again, put on your math brain.
Stop. Keep reminding.
Matthew?
I'm still thinking.
Anybody?
We use the formula.
What's with the whole minus 1 bit here? Why is that in there? Matthew?
Because the first term isn't.
Matthew saying something smart. What's up?
The first term isn't always the same as the other terms.
Okay?
Like, it could be like negative 5.
So-
you could add 2.
Okay, so the first term isn't dependent on what the pattern is, right? The pattern is consistent, but the first term can be wherever you want to start. If we're looking for the 12th term in the sequence, going back to the first one here, if we're looking for the 12th term and we start, we're given the first term, how many times are we actually adding 4? If we're given the first term and want the 12th term, how many times are we actually adding 4 here? 11. That's why we subtract 1. Because that's how many times, 11 times, we are adding 4. Okay? That's minus 1 is there because you're given the first term, which means you're only actually adding 4 11 times. You're only actually subtracting 3 79 times because the first term is given to you. Okay? Last one, do it on your own. If you are done, make sure it looks like this. $101st term equals negative 50 plus 101 minus 1 times 71. That's how it should look. Who has got an answer? Kyle.
Is it negative 355,000?
Nope.
No.
I got it.
Henry?
Is it 7,150?
7,150. Do you have a second on that?
Hang on.
What did you get, Lakely?
I got 7,103.14.
Well, that's not right.
So we got 3.1.
Try that one again.
Wait.
Olivia?
I got 7,050.
7,050.
That's what I got.
7,050. 7,050.
7,050.
If you did not get 7,050 and don't know why, ask a neighbor if you can't figure it out.
I see where I went wrong. I didn't plug in the negative.
Ask me.
I'm so proud of myself. I wasn't even listening at the time.
Matthew.
I got 6,950 because I accidentally put 7.
Gabe, turn around, please.
I'm just that smart.
3, 2, 1. You're quiet. Peyton. By what?
The whole thing.
Okay.
I'm just confused.
Okay.
Like, I understand it, but I don't.
You don't know how to put it in your there, or you don't
No,
know where?
I know. I know how to put it in my calculator.
You don't know where the numbers go?
Yeah, kind of.
Okay. So going from this given formula, okay. If I tell you the first term is negative 50, that's where we start. That's why A1 is negative 50.
Yeah, I
Okay.
see that.
Boys, we want the 101st term, which is why this n and this n are both 101. Right? This essentially says the answer to the 101st term is whatever this formula is. That's why 101 also goes in for the n here. Because what we're saying here is we want to start at negative 50 and then add 71 100 times. That'll bring us to the 101st term. So that common difference, that pattern 71, goes in for D after the parentheses.
Oh,
This
yeah.
tells us we're essentially adding 7100, right, to negative 50.
Oh, yeah, that makes more sense. I see it now. Because the n equals 101, so
Yep.
you put it in for the n's, and then
Claire.
A1 equals negative 50, so
Adding?
A equals negative 50.
Yes,
So yeah, it all comes together now.
great.
Hey,
Okay. Anyone else? Questions? Okay. Your job says, first of all, determine if each sequence is an arithmetic sequence. If it is, identify the values of A1, N, and D, then find the nth term. So when this says, find A12, what does that 12 represent?
The 12th number.
12th number of the sequence, so which variable is it? N. N equals 12, because that's what that is right there. Okay? What is our first term of the sequence? Where does the sequence start? 15. And now we've got to determine whether or not we can actually use this formula. Because remember, if that pattern is not constant, addition or subtraction, this formula does no good. So we look at the numbers in the sequence and we say, what's going on between 15 and 22?
You add 7.
Add 7, 22 and 29. Add 7, 29 and 36. Add 7. Is our pattern constant with addition or subtraction?
Yes.
Yes. So what is the value for D? Positive 7. Okay? Again, how we got these three variables is I read the statement, find A12, that means 12 is N. Okay? These numbers are the same. The first term, I just looked at the sequence, where does it start? The common difference, we had to figure out what's the pattern. And that's positive 7. So, in our formula, which again, write it out here, A1, or AN equals A1 plus N minus 1 times D. AN is the 12th. Our first term is 15. our n is 12. I almost read 15 again. Our n is 12. And we're multiplying that by 7. What do we get? 92? 92? 92? Anyone not getting 92?
I'm getting 92.
92.
I didn't get
Okay. 92. So, your homework is to work through the rest of the page. Okay? The other three are very similar to this. You need to identify what each variable is based on the sequence that's provided. What term are you finding? That's your n. Where does it start? That's your first term. And then is there a constant pattern with addition or subtraction? Matthew.
The third one doesn't make sense.
Why?
It does.
Is there a constant pattern?
No.
So can you use the formula?
No.
So you don't use the formula.
So you just do
Okay.
circle with.
Do I just cross it out?
Yep. Well, don't cross it out. Just say can't use the formula.
No.
Okay.
Or I can just put a circle with.
The word problem. Your bank account currently has $160 in it. Consider this day one. Okay? You begin adding $8 every day. How much money will be in the account on day 50? What is our N? What is our A1? What is our D? Your bank account currently has $160. Consider this day one. What does that 160 represent?
A.
A1. That's where we start, right? We're starting with 160 bucks. You begin adding $8 every day. What's the 8?
D.
8.
D.
Yes, 8 is 8.
It's D.
Yeah. What did you say, Kristen?
Huh?
What is 8? Did you say 8?
Grayson.
Christian, sorry. What did you say? What I calling you?
8.
8. Yes, 8 is the 8. Which variable does that represent, Christian?
The D.
Yes. This is the pattern. This is the common difference. You're doing the same thing every day. You're adding $8 every day. That's the pattern. How much money will be in the account on day 50? What does that represent? Better is the only variable left, right? But we are projecting. We want to know, we're on day one, 50 days from now, what will the account balance be? So, we are looking for the 50th term, A50, the answer to the 50th term equals where we start, A1, 160, plus n minus 1, or 50 minus 1, times
I got it.
8. And what do we have as a result?
I will get 552.
552,
Good job,
552,
I got 52.
552.
Good
Okay?
job, Chris. Got it correct.
So the 50th term, you'll have 552 bucks 50 days from now.
That's not a lot of money.
I'll take it. Questions, comments, concerns, complaints, compliments, congratulations, criticisms. Okay, Henry,
Congrats on teaching us something new.
you're welcome. Hopefully I did a good job.
Congrats on being learned.
No. This is homework due on Monday. Practice test will be Monday. Test will be Tuesday. That's how you math.
Don't forget to like and subscribe.